Hello students, a very warm welcome to this first lecture on electrostatics. It's going to be a very basic lecture, but given that this is the first lecture, I hope you would stick to the rest of the parts of electrostatics because it is very important, and from this you will start building all your foundation required to solve even more advanced problems in electrostatics. So this is going to be like a super easy lecture. So make sure you are attending all the lectures from now on. It's for you guys. So don't miss out any of these lectures on electrostatics because it is one of the heavyweight topics in your JEE Mains. And that being said, you're on JEE English by Unacademy, India's leading and largest test preparation platform. And guys, let me introduce myself to you. I'm Murlidharan. I completed my MS in Electrical Engineering from University of Colorado Boulder, and I'm also an IIT who completed BTech from IIT Guwahati. I have 4+ years of experience tutoring and preparing students for IIT JEE, and I filed 25 patent applications in India and abroad. And before we dive deep into this lecture, let me tell you something amazing. Hi Rohit. So yes, Rohit, we are again going to get started with the quiz. You can quickly, enter this code. So today's quiz is going to be on capacitors. So we'll be having a mini quiz on capacitors, and you can note down the code, Rohit. It's going to be 1015662. Hi Rupesh, hi Rohit. Yeah, you can quickly log in, guys. And students who are totally new to this, let me tell you how to get on to the Unacademy quiz. So it's a free of cost feature. You don't require any subscription etc. to attend this quiz. So make sure you're attending the quiz because you get to attend a lot of PYQs, JEE Advanced and JEE Mains kind of questions in this quiz. So first of all, you need to download Unacademy Learning app. You'll download that from your Google Play Store or App Store by typing in Unacademy, and the first search result is anyway going to be Unacademy Learning app, and then you'll click on the install button. And post that, guys, you need to click on to the once you click onto the extension, you'll find hi Rupesh, hi. You can get on to the quiz, guys. Yeah. So the code is 015662. That's good, Rupesh. Yeah, it's going to be totally like a lecture from basics. So I guess we already have one participant, and you need to click on to the plus, and then you'll click on the extension bar, and then you'll click on the plus, and then among the 5 tabs on the bottom, you'll choose the middle one, which is going to be the test, and then you'll click on join quiz, and post that, you will see a pop-up like this. Over here you will enter 015662. Hi Priyanshu. Yeah, you can quickly get onto this quiz, guys. And yeah, today's lecture is going to be really interesting because it's the basic, it's the beginning of electrostatics. And post this, I believe everything will be even clearer on capacitors. We have already completed capacitors. It's anyway more related to it's related to electrostatics, but more related to current and electricity. So you can complete the lecture on current and electricity and capacitors if you haven't done it yet. So make sure you're attending and completing all the lectures. So yes guys, we will wait for another 2 to 3 minutes so you can quickly enter this code, and we can get started with the quiz. You will find the extension on the left hand top corner, Rupesh. So yes, students, make sure you're understanding these topics. And one more interesting thing is this year a lot of questions in your JEE Advanced were primarily in physics, and also most of the subjects are primarily from the first year. Given that it was from the first year, maybe you can expect questions next to next year, and mostly from your second year topics. And we will have a session tomorrow. We'll be analyzing your JEE Advanced paper, and what could be the expected rank and marks in tomorrow's session. Don't miss out tomorrow's special session. It's going to be useful for both 2021 aspirants and 2020 aspirants who are planning to get into college, or if you have any other plans. So yes guys, we will wait for another 2 more minutes, and then we'll get started with the quiz. So you can quickly log into the quiz, and post that we'll get started on the quiz. And capacitors is a really important chapter, guys, not only just for of course it's very important for your exams, but also for your future. It would be a very, very useful topic. So do not ignore those kind of topics. And that being said, electrostatics is also a very practical subject, and you can typically expect questions in combination from this topic. And in electrostatics, one thing is you have to make sure you are thorough with most of the concepts, because anything can be asked from anywhere. There are like two subjects. One is going to be your electrostatics and the other one is electrostatics and magnetism, and as well as your mechanics, where you can expect different kind of questions, be it in a JEE Mains and JEE Advanced, because they are they have been asked for so many times, and they have been asked in the exams for quite a few years, I mean, like compared to rest of the topics. So this is something where you can expect kind of challenging questions, be it in electrostatics or mechanics. So that is the thing that you don't want to miss out. And this is also kind of an a part of electrostatics or current and electricity, you can say. So yes, we will get started in another 2 minutes, guys. Hi Rohit, yeah, I've seen you. Awesome, amazing guys. And make sure you're understanding how to work around them. You can get your notebook, guys, and share this video. Ask your friends to come on board for this quiz. And students, get your pen and paper or notebook and pen, and start working around the problems. It's very important that you understand how to work around the problems. I know it's going to be 80 seconds per question, but still, there would be some ways to work around these kind of problems. If not, try to understand at least the approach, if the approach has gone right, and later on you can verify the answer. Keep noting down the answers, keep noting down the questions. So that is the most important part. Amazing, Aditya. So yes, Lokesh. Hi Lokesh. Hi Aditya. Hi Rupesh. Hi everyone. A very good evening, guys, and a very warm welcome to JEE English. And you're on JEE English, which is the nation's first channel where you will have all your lectures for your JEE preparation exclusively and completely in English from basics until advanced. That's the beauty of this channel. So don't miss out any lectures. Stay tuned, be regular, and we are going to get started with the quiz. And students, if you haven't yet joined the quiz, you can quickly join the quiz by entering this code onto the quiz feature on your Unacademy learning app. It's a free of cost feature, so quickly download the app if you don't have one. If you have one, do get on to this this thing, this quiz, and it's going to be a very interesting quiz. So make sure you are okay. You work around it. It does not matter, if you get the answer or if you don't get the answer. And anyway, it's the beginning session. Even if you have missed capacitors, go and attend the lectures after this lecture, because this is going to be the basic lecture that you want to get started for your second year. But that being said, you would have to also cover capacitors, guys. Capacitors, current, electricity, magnetism. Try to maintain completeness in each topic, given that your syllabus has been spiked in the last few years. So you need to make sure you are maintaining completeness at least in few of the topics. So yes, let's get started with the quiz then. I guess we'll wait for 1 more minute and we'll get started with the quiz. So yes, we'll wait for 1 more minute, guys. Yes, Rohit, yeah, and Lokesh, yes. So I believe we'll get started by 7:40 sharp. As soon as the clock over here ticks 7:40, we'll get started with the quiz, and post that we are going to have a very interesting lecture. It's the beginning, and it's one of the most important topics for your JEE Mains and JEE Advanced preparation. All right, and I guess we have to begin the quiz. All right, guys, get your pen and paper. Even if you haven't downloaded the app, try to solve it and try to guess the answers. And the quiz begins. So I'll read out the quiz. In this case, I'll try to give you a hint. And so let's first of all read the quiz. I guess this is doable. A parallel plate capacitor of area A and separation D is provided with a thin insulating spacers to keep its plates aligned in an environment of fluctuating temperature. If the coefficient of thermal expansion of the material of the plate is alpha, find the coefficient of thermal expansion alpha s of the spacers in order the capacitance do not vary. All right, actually we have done a very similar question in the very beginning, so I guess this is easy, guys. So do remember how do these spacers impact your let's say your plate is undergoing thermal expansion, and Ansab, a good question. So Ansab is asking that any chances that the JEE exam date might be changed. It is quite possible, given the current circumstances. It is quite possible. The JEE Advanced exam date can be changed. But that being said, yeah, try to attend the classes. It does not matter if it is changed or it does not change. All right, guys. All right. It's just the beginning, so it is fine. It's totally fine. So try to answer the question, and later on you will come to know the correct answer. But anyway, the answer was A. So yes, you need to maintain the distance between the capacitors, irrespective of the yes. So yes, let's get started with the second question. A battery is used to charge a parallel plate capacitor till the potential difference between the plates equal to the EMF of the battery. This is a very interesting question. I believe we have discussed this concept. If not, I'll bring it up even in the electrostatics chapter. So a battery is being used, and I mean, this is actually conceptual, guys. There is no calculation involved in this. You need to quietly think about the answer. I mean, if you know it, you know it. Probably that is how it's going to be. So they're asking you what is the ratio of the energy stored. We have done questions on this, right? We have done quite a few questions on this, I believe, during our capacitor lecture series, where we had different kind of capacitors. We assessed what is the energy work done by the battery, and what is the energy stored. And but this is not like multiple capacitors and etc. This is basically only one capacitor. And if I have to remind you, there would be some like heat loss. So think about that heat loss, and maybe, so they're asking you energy stored in the capacitor to the work done by the battery. So what it should be. So I think we did even more complicated. Amazing, guys. It should be 1/2. So half the energy is lost in the work done. Hi Akansha. Yeah, half the energy is lost due to like heat losses. And so rest, I mean, basically how it loses it's through the resistor, while the charge is being like while the polarization or the charge is being accumulated on the capacitor. During that process, there is current flowing through the resistor, and the energy is lost. So it would be half CV square would be the energy stored in the capacitor, whereas the work done by the battery would be CV into V, or how much charge work done on to move so much charge Q to the capacitor in like a steady state. So that would be like CV square. So you get 1/2. For the circuit shown below, which of the following? Yes, we have also done similar problems, guys. So think about it carefully. You can join them both, right? You can join them both. So yes, think about it carefully. One way of working around such kind of problems is you can apply loop law. The simplest way is you can apply loop law. This is the standard thing I talk about. Hi Nihal. Nihal, you can check it out on Unacademy. Yes guys, so one of the standard things is try to apply the loop law and try to work around it. We have done quite a few number of problems even around this, so I believe this is an easy question for you. So the answer should have been D. And yes, let's get into the next question. Really good, guys. Really good. Ashwin, really good. Akansha, really good. Rohit, and really good. Rupesh, good. Lokesh, try attending more questions. So I believe again a similar kind of question. Whether it is the same one, I think the capacitances might have changed. All right. So the thing is, so what is being asked? So yeah, there are multiple switches in this. Yes, there are multiple switches in this. So carefully think about this question. So the code is going to be alright, guys. You can work on the question. Just a moment, I'll share the code with the rest of the students. So the code is going to be 015662, and you can type in this code on once you click on to the join quiz. You will see this pop up. Okay, first of all, you need to click on the join quiz by clicking the extension, by choosing the plus. I believe you already know this, but if not, you'll click on the extension, choose the plus, and click on the test tab, and then you'll type in this code, which is going to be 015662. Right, this is what you need to type in on your this is going to be a quiz ID, so you can quickly type in this ID. And yeah, if you're not aware of the process, just click on to the extension, choose plus, and then choose test, then join the quiz, and then it will be this ID 015662. I think 50% of you answered it correct. It's fine, it's really good though. Good, really good students, really good, amazing work. And anyway, keep attending. Hi Rupesh, yes, and let's get into the next question. So let's analyze this question. I don't think this is a pen and paper question. Let's have a look at it in the circuit given below. So if you're not aware of the code is going to be 015662 students. You can type in this code on your Unacademy learning app, quiz, this thing like feature, and you can attend this quiz. In the circuit shown, the switch has been closed for a very long time, so steady state, okay, and the switch is opened at time t is equal to 0. Switch is open, it remains open for a very long time. Okay, no, we have 10 questions. Krunal, hi Krunal. So yes, so yeah, in the circuit shown, the switch S has been closed for a very long time. At time t is equal to 0, the switch is open. So initially you will charge the capacitor, then you open the switch, it remains open for a long time. Then which of the follow after which it remains open for a long time, after which it is closed again. Okay, then which of the following is true? I think so. Let me just quickly brief you through the question. Initially, I think the answer is C. So initially, you have completely charged the capacitor by close. Even not, you can charge the capacitor. So that statement wasn't correct. So anyway, if initially you charge the capacitor, assuming that there would be voltage drop as much as on the parallel resistor, and then again you are opening that switch. And then again you're closing it, and based on that you could have solved it. And I think a similar kind of question was asked in previous year JEE Advanced, and so be careful while solving these kind of questions. It's an easy one, but you don't want to miss out the basic concepts. So parallel plate air capacitor as capacitance C, when it is half filled with a dielectric constant 5, the percentage increase in the capacitance will be. So are these capacitors in parallel or series? This is even an easier one. Are these in parallel or series? They are basically in parallel, right? And that being said, half the area is only covered. So now it has a dielectric constant 5. If this is this initial entire thing was C, all right, this is going to be C by 2. This is going to be 5 into C by 2. So rest, you need to know what to do when it's in parallel or series. So rest, I hope you know it already. So yes, and do notice the percentage increase in capacitance is only being asked. Okay, so what would be the increase? Increase would not be, all right guys, it should have been D. So it would be 5 into C by 2 plus C by 2. That is going to be, because since they are in parallel, so it's going to be 6C by 2. So it should be 3C. Initially it was C. So there was a 200% increase in the capacitor. 3 more questions, Kunal, and I believe this 7, 8, 9. So 4 more questions. I'm really sorry. So we have 4 more questions to go, or 4 more questions to go. So yes, this is an AC based question. So we haven't completed AC yet. Anyway, you can try to run this question. A circuit consists of 2 capacitors, a 24-volt battery, and an AC source. So there's a DC and AC. The AC voltage is given as 20 cos 120 volts into T. So omega, you understood what is the value of omega, where T is in seconds. And the charge in the capacitor is a function of Q2. Of time Q2. So multiple options are given to you, and how would you assess the charge? So one, you would have a steady state thing, and the other one would be where you will be assessing the maximum energy stored in the capacitor C1 and C2. So there are 2 capacitors in parallel, and you can sort of, while calculating the current, you can take the combination, the net combination. Yes, Divyanshi, yeah, good question. So yes, students, we are going to get started with the plus, and we will be beginning with optics. So we'll have anywhere around 60 sessions to completely cover your optics, and we'll be having 12 to 11 quizzes. So we'll be covering both ray optics and wave optics in this like plus course. So make sure you are attending it if you're on the plus platform. If you're planning to enroll soon and get started with this thing, because it carries anywhere around 12 to 15% weightage in your exam, and it's independent of the rest of the topics. If you haven't begun with any of the topics, you can get started with the optics, and it's quite interesting, and it will also be useful in future if you're like getting into physics or electrical engineering, or if you're getting into any sort of research, or let's say you're getting into a company in R&D role, because the future is optics, guys. So make sure if you're already on Plus, enroll to the course. It will be soon launched. We are going to launch a full-fledged course on optics, and we'll be covering everything around optics that you need for your JEE Mains and JEE Advanced. It's going to be super extensive, but attend from the day one. You don't want to miss any of these sessions, since optics is also not only that it's interesting, as I told you, 12 to 15% weightage, be it in your JEE Mains, JEE Advanced or NEET, and that is like 20% of weightage of your second year, 20-25%. Okay, so don't miss out any of the, 20%. Let's say this year there was more of second year in JEE Advanced, first year in JEE Advanced and JEE Mains, but that may not happen every time. There are reasons that why you would have got the first year topic more. So I guess yeah, good guys. I think we did a very similar question. You can probably even watch one of the a video on I don't exactly remember, 5th lecture or 6th lecture, where we have covered a very similar question. So really good, guys, really good. Okay, nice. So Krunal, you can attend the lectures on capacitors, guys, if you haven't completed capacitor yet, and so do attend the lecture. Don't miss out the lectures. And if you're on Plus, not only you're going to attend the lecture, but going to complete the entire program, the quizzes, doubt clearing sessions. You will have dedicated doubt clearing sessions on each individual topic. You will have quizzes on each individual topic, and as well as you'll be facing some mega quizzes. So yeah, that's a structured program. If you're attending on YouTube, do complete the previous classes as well. Don't miss out any of the classes. And we completed current electricity, capacitors, units, dimensions and measurements, and which comes also with error analysis. Of course, we're talking about measurements, and also we completed vectors. So we completed the primary topics like projectile motion, etc. So do complete them. And in fact, there was a question on projectile. There's pretty much nowadays you can see questions on projectile motion. Earlier there weren't much questions in your JEE Advanced from projectile motion, but nowadays you're getting questions on projectile motion. So do attend the projectile motion lecture as well. The shown figure of plates, capacitance is outside the distance. All right, I think I did not read the question, but anyway, 50% of you have answered the question correctly. So I believe this is going to be the last question, guys. And post this, we'll have an interesting lecture, very interesting lecture, very basic lecture. But if at all, if you feel this lecture was too easy, don't miss out the rest of the lectures, because this will build the entire fundamental for you going forward in electrostatics. And yes, of course, but let's see if you're able to answer all the questions. I believe you'll be able to answer all the questions, given that we will be understanding everything in the session. But there will be a few tricky questions in your exams, and you don't want to miss them out. Maybe not necessarily in JEE Mains or JEE Advanced, or maybe not given directly, but it may be given indirectly. So in today's lecture, we are going to cover conservation of charges. What is a charge? How do these charge behave? And what is really a charge when you're talking about a charge? Okay, so that is going to be the basic lecture, the very basic lecture. But given that it's a very basic lecture, you don't want to miss the very basic lecture, because rest of the topics will seem a little bit tougher if you miss few fundamental concepts. And not only now, it will be also useful in future. So don't miss out anything. So two identical capacitors having the same capacitance C, one of them is charged to potential V1 and the other one is charged to V2. The negative ends of the capacitor are connected. So basically they are connected in the opposite fashion. And when the positive ends are also connected, the decrease in the combination is going to be. So whenever you're doing a negative connection, do remember that there will be a transfer of charge. So the charges has to be balanced. So I think this was a pretty simple question. So there will be a potential that will be established between them. The number of charges on the plates have to be, the potential drop across, if you do a loop law, the potential drop across them has to be same. So accordingly you can work on the question. Really good, Rohit, really good. Good Ashwin, good Rupesh, good Akansha, really good guys, really good Lokesh, really good Kunal. But do attend the lectures if you have missed the lectures earlier. and we will get into this lecture. And yes, we are going to get started with the first and the fundamental lecture on electrostatic, guys. And students, that being said, the quiz challenge is complete, really amazing. And if you are not yet on our Telegram channel, do download the Telegram app if you don't have one from your Google Play Store and App Store. And just to click onto this link is available in the description box below. And once you're on this Telegram channel, you will be able to get all the timely updates on, these not only just lecture sessions are being conducted on JEE English, we also conduct a lot of strategy sessions for you to understand how to prepare and what should you do for your let's say even for your college or for your JEE preparation, etc. So if you are already on the Telegram channel, well and good. If not, do get onto the Telegram channel. That way you will be able to get all the updates on time on whatever is happening on JEE English channel. We are conducting so many lectures around your JEE Mains, be it your subject or be it strategy. And that also being said, guys, we have completed the entire of units, dimensions and measurements on the Unacademy Learning app as well as on YouTube, but different kind of questions are covered on Unacademy Learning app. And we might be having a DPP session coming Sunday on Unacademy Learning app. So don't miss it out. Cover all of these lectures. Very easy one. And typically you get a question or two in your JEE Mains and also in your JEE Advanced, but in an indirect manner. So do cover these topics. They are very important and very easy. That is something that you don't want to miss out. Even for your JEE Advanced, when it comes to your JEE Advanced, this is going to be the cakewalk topics that you want to cover. I mean, especially if you are in second year or even first year. First year, this is going to be something that you need to cover. If you're second year and if you're feeling that, you need to move strategically, this is one of the lectures that you want to cover. So to attend these lecture sessions, you need to first of all download Unacademy Learning app. If you don't have one, do download Unacademy Learning app from Google App Store and Play Store. And I believe many of you are attending the quizzes, so you already have an Unacademy Learning app, guys. So that's really good, Rohit. Really amazing. So that being said, guys, if you are looking for a Champions tool and a package, or let's say a tool for your complete preparation, so a complete package for your preparation, we have one for you. That is going to be Unacademy subscription platform. And the best thing about Unacademy subscription platform is you'll undergo a structured program that is required for your JEE preparation, be it your JEE Mains or JEE Advanced. So it's going to be an extensive and an intensive, a program where you'll be undergoing, a very systematic, what do I mean by systematic program is you'll be attending, for an example, you'll be attending the optics course, you'll be attending the lecture sessions, you'll be attending the quizzes, and you'll have dedicated doubt clearing session, and you will be completing each and every topic, on an Unacademy Plus platform. Not only that, we have the best educators across the nation on an Unacademy Plus platform, and we also have popular authors, the books that you read, the authors who wrote the books that you read also, come and teach on Unacademy subscription platform. This includes DC Pandey sir. So don't miss out any lecture if you're on Unacademy Plus. And the beauty of Unacademy subscription is that you get to attend a structured program and you attend a lot of test series and quizzes that really prepares you for the test. I'm not saying that you can't prepare from JEE English, since you get all the lectures on JEE English as well, but there is a difference between choosing to stay dedicated and undergoing intensive lecture sessions, not only lecture sessions, live interactive lecture sessions, but on a technologically equipped platform. And moreover, the kind of program that comes with daily that comes with quizzes, test series and daily lecture sessions that is required for your preparation. And that being said, guys, all you need to do to get onto this subscription platform is click on the extension, choose plus, choose IIT JEE as your goal and get the subscription. That's all you need to do. And that being said, once you have chosen the goal as IIT JEE, you will be preparing for JEE Mains and JEE Advanced, and you will be enrolling in the correct kind of program accordingly. And that being said, guys, the Unacademy subscription is also quite economical. It comes at a cost of only 2,100 per month if you're going for a 24-month subscription. And to get to this price point, you can apply Murli Live coupon. So that will get you the best discount that you will avail on the subscription. So it's pretty economical. So this is typically meant for 9th, 10th and 11th, primarily for 11th, I guess. Also 9 and 10 students start early, so that would help you understand topics quickly. And hi Kavya, hi. So yes guys, and that being said, we also have convenient payment modes for you. You can pay in parts. You may not want to go through the burden of paying all the fee at once. So this is an in-house feature by Unacademy. You can pay in parts by choosing this option on your app. And we also have no cost EMI for you, which also takes away the burden of paying all the fee at once. We also have other traditional payment methods. You can check them out, like debit card, credit card, UPIs, etc. And that being said, guys, if you're a long-term dropout and if you have 1 year for preparation, and we also have programs accordingly, and this subscription is also quite economical. It's only going to cost you less than 2,900, 2,888 per month. So that is pretty economical. And to get to this price point, do apply Murli Live coupon to avail the best discount on your subscription purchase. And that being said, guys, we have 6,000 plus materials and the dedicated programs for your preparation. Be sure to enroll in the right kind of programs. If you're already on the Plus platform, go through that structured program. That structured program is meant for you, for your preparation, for your JEE Mains, to achieve your dreams. And that being said, guys, we are on the lecture 1. Knowledge just has the beginning, but it does not have an end. Let's begin with the initial phases of electrostatics. So do share the video. So since this is the first lecture, many students may want to attend it. Do share the video. Do not forget to share it and like the video, guys. And that being said, what is a charge? So hi. So charge, yes, quiz is over. The quiz is over, guys. I'm sorry, the quiz got over. So what is a charge? Actually, charge is a physical property. It's a fundamental property which causes a matter, or like any any material, like assuming that it has net charge. So some systems may not have net charge. For an example, an insulator that has not been charged, etc., or even a metal that has not been charged. So in these kind of things, they don't experience a force. But electric charge as such is a physical property. When kept in like an electromagnetic field, will experience a force. So it causes the matter to experience a force when placed in an electromagnetic field. For an example, if you see over here, this positive charge is experiencing the force in the direction, like in the net direction of the electric field. So we'll understand electric field moving forward. So this is all about charge. It's a fundamental physical property of a matter which causes the matter to experience a force. Okay. Hi Hoshori Kutari. Hi. Yeah. So let's get into hi Haradhya Sharma. Hi. So that being said, guys, as I told you, charge is a fundamental property. What does this fundamental property mean, and what are the properties of charges? So so as I told you, a body or an isolated system may not be charged, but let's say if it is charged, in this case, as you're seeing over here, like the someone is like pulling out this negative charge to do some work, but this negative charge is getting attracted to the positive charge, and the positive charge is repelling. Okay, so it's a fundamental property. And that being said, what it should do, it should exhibit some sort of electrostatic attraction or repulsion in presence of another matter. So you are wondering, another matter, should it be charged? May not be necessarily. In cases of electrostatic induction, so for an example, let's say you rubbed a rod, and this is an electroscope, but anyway, if you rubbed a rod and if you tried to pick up the pieces of paper, you would have seen that it causes an electrostatic induction and picks up that paper. So that's a very good example of a charge being a fundamental property which is exhibiting like sort of an electrostatic attraction in that case. I mean electrostatic attraction in that case, but that is like a property of a charge. This thing, unlike charges attract, unlike charges repel. So this is a basic thing. I hope everyone knows this. If you don't know it, just understand that it is how it works. So unlike charges attract and unlike charges repel. So positive charge would repel a positive charge, and a negative charge would repel a negative charge, and a positive and negative charge will get attracted. Okay. So this thing is also a fundamental thesis for Coulomb's law, like when Coulomb's law was defined, and while designing that, torsion, I'm not exactly getting the name, there is an instrument using which you will measure the, the Coulomb's law experiment was conducted, and torsion balance. That torsion balance was invented based on this principle. If this principle wasn't aptly used, I know this is a very basic thing, but if this principle wasn't aptly used, the torsion balance couldn't have been designed efficiently. That being said, yes, positive charges and negative charges attract. So that is like the unlike charges, and you understood like charges means which something that has the same kind of charge. In this case, positive repels positive, negative repels negative. So that being said, by convention, the charge of an electron is negative. Okay, indicated with minus E. So if you notice, minus is over here, minus E, and while that of proton is positive. So what do we mean by electron is negative? Why are we talking about it? And what is the reason behind talking about electron and proton? Does it make any sense? Of course, it does make any sense as we move and understand the charges. Okay, this is like the fundamental not the fundamental, the fundamental thing behind charges. We'll understand that point. Stay tuned. So yes, so by convention, if you the charge of an electron is negative, while that of positive, this is quite clear, I believe. And that being said, yes. So what is the charge carried by one proton? 1 plus 1 E, while that of electron is minus 1 E. Okay, so I believe this is also quite clear. So that being said, guys, generally we are not talking about protons. That's just a convention. Okay, so whenever we are talking about positively charged or negatively charged, it is basically indicating that loss or gain of electrons. So let's say we have a neutral atom like this, in this case, and let's say it loses electron. If it loses electrons, the net charge of the system is positive. Okay, the net charge of the system is positive. So there is generally no such thing as gaining of protons. It's a fundamental thing, you need to understand this. But there is something known as gain of electrons, gaining electrons, and losing electrons, but nothing like losing protons or gaining protons. So hence, a positively charged, whenever we're talking about a positively charged, ion, we generally call it as cation. So you can remember this by cat. So this is one of the tricks that was taught to me. So cat means positive, hence cation means positive. Okay, and gain of electrons makes anion. Okay, so anyway, forget this point. But the thing is, there is no such thing as gaining protons. If you lose electrons, the overall system is positive, since you lost the electrons but protons is still present in the nucleus, hence it would be positive. And if you gain electrons, if some electrons has been gained by that system or by that ion, it's going to be a negatively charged one. I don't know, Krunal, good question, but I don't know. So let's get into understanding rest of the things about charges. So we spoke all about charges, etc. And now how do you call this charge? And is there any units? Yes. So an SI unit of electric charge is going to be coulombs, generally indicated with a symbol C, named after Coulomb d'Augustin. And that being said, guys, it's not a fundamental quantity. So charge is not a fundamental quantity. What do I mean by that? Do attend units and dimension classes if you have. I think it will come up in the first lecture itself, I guess. So charge is not a fundamental quantity, it's a derived quantity. Hence we say that the coulomb is basically the quantity of charge that passes through a cross section of a conductor carrying 1 ampere of current for 1 second. So coulomb would typically be written as 1 ampere into 1 second. Okay, that is how you would define charge. The reason is the charge is not, this is the SI unit of charge, but the charge is not that's how you define coulomb. The reason is the charge is not a fundamental quantity, rather it's a derived quantity and indicated with a symbol C. Okay, that's true. Yep. So, and the amazing thing about the charge, it is quantized, guys, and the elementary value of charge is 1 electron. Okay, 1 electron, it can be like 1 proton, 1 electron. What do I mean by that? You will get to understand. But charge is always quantized. It cannot exist in fractions. I can't say 1/3 of electron has been transferred or 1/3 of electron has been lost. Okay, so let me give you a little bit more clarity. So this is something that we can't say. Let's say I'm going to say 1/3 electron has been gained by the system. This is something that I can't say. Similarly, you can't say something like 2/3 of electrons has been lost. Okay, that means positive 2/3. But this is something that you can't say because charge is quantized, and this thing was experimentally found. Okay, this is something that you can't state, and this is something experimentally found, and the individual elementary charge is how you are going to measure. I mean, you are measuring in coulombs, but coulombs is an SI unit, but the elementary value is E, which is nothing but the amount of charge present in one electron. In this case, it's basically one proton. You're not seeing any negative sign. There should have been a negative sign if I'm talking about electron. But like if you take the modulus, the absolute value is going to be 1.6 into 10 to the power minus 19 coulombs. So always whenever, I mean, this is still an approximation. Okay, if you remember, we have discussed this thing. These are all like found out experimentally. So this is an approximation, but to give you like a gist of things, what I'm saying is everything should be a multiple of 1.6 into 10 to the power minus 19 coulombs. So if it's not a multiple of 1.6 into 10 to the power minus 19 coulombs, then there is something that has gone wrong in a past experiment, or maybe whatever we are whatever kind of problem is given to you. So the thing is, charge is quantized. It always comes in integer multiple of E. So integer multiple of E means, for an example, if I'm going to state a charge Q, it's going to be N into E. Number of, in this case, it's going to be, I mean, this typically saying if it's plus, okay, if this is plus, then let's say the number of electrons has been lost. Okay, so how many electrons would be lost in 1 coulomb charged material? If you're thinking about it, there would be 6.25 into 10 to the power 18 electrons. So these many number of, a huge number of electrons has been transferred from the system. No, charge is not a vector, guys. Charge is scalar. Okay, charge is not a vector. Good question though, if you're just beginning with it. Yeah, charge is not a vector, it's a scalar. Alright, so that being said, yes, because charge does not have any direction. As such, it's a good question though. If you start thinking about it as a scalar or a vector, how do you define a vector and scalar for charge? Really good question. But that being said, but anyway, for your exams, you have to move by whatever is in your syllabus and whatever is in your books. So don't dive deep into each concepts at the moment, but later you can do it. Okay, you have vast syllabus and you want to cover it. So yes, that being said, charge should always be quantized. If it's not quantized, there is something wrong in your measurement, in your experiment, or maybe the problem is given that way, and you need to understand that probably something. So yes, fraction values cannot be existing and should be a multiple, I mean like an integer multiple. It should be 1, 2, 3, so on till it can be 100, 500, 600, 1000, and in this case this is 6.25 into 10 to the power 18. So a number of electrons that has been lost in 1 coulomb is 6.25 into 10 to the power 18. Maybe something that you want to remember. Two things that you want to remember. One is 1.6 into 10 to the power minus 19 is the elementary value. Okay, this is the multiple value, I mean like E, value of E. And the other thing that you want to remember is number of electrons lost in 1 coulomb, or number of electrons gained in minus 1 coulomb is going to be 6.25 into 10 to the power 18. Okay, so a very important property of charge of an isolated system is always conserved. Okay, so charge is a conserved property. The final, if it's an isolated system, the final system, let's say 2 rods you have, and if you're doing some electrostatic induction, or like a paper and a rod example, okay, a classic example where you rub with an like an insulator rod, and then you try to pick it up, pick up the paper, then you observe that you're able to pick up that paper. Similarly, you can do that experiment with your comb. If you have a comb at home, you can just sort of rub your hair. So these are like the classic examples that you come in your previous classes, I believe. So you can try them out, and you'll come to know still the total amount of charges present in an isolated system remains constant. Okay, regardless of the changes within the system. What do I mean? Like, somewhere the charge can be gained in the system, somewhere the charge will be lost in the system. So the amount of positive. So these are all the basic things that you need to know before we get deep into electrostatics. But these are like the very, very basic things. Q is equal to NE, something you don't want to miss out, because you will carry this in your current electricity. Maybe in basic problems you're missing out and you're thinking what is happening. One is like, what is the value of 1E? It's basically 1.6 into 10 to the power minus 19 coulomb. And how many electrons are present? I have been lost in 1 plus 1 coulomb charged material. So it's going to be 6.25 into 10 to the power 18. I know if you remember just 1.6 into 10 to the power minus 19, you can derive the rest, but one thing you would have to remember. And charges will be always quantized, and charge is a conserved property. The total amount of charges present in an isolated system remains constant regardless of the changes within the system itself. So some amount of positive charge can be gained, and some amount of negative charge will be lost from one part of the system, but the other part will gain it. Okay, so that being said, you can also say it as the amount of positive charge minus negative charge remains constant, and that also can be denoted by Q initial of the system is equal to the Q final of the system. Okay, all right. So charge is a conserved property. Charge is always quantized. And for an example, in this case, if you have noticed, so this is what I meant by, regardless of what is happening within the system. So if you are considering this entire thing to be a system, so if you have noticed, these two, like objects form a system. Initially, this had 8E charge and this had 0 charge. Now it has become 4E and 4E. Once you brought them in contact, assuming they are like, spheres or something, identical spheres, identical conducting spheres, you brought them in contact and it gained 4E and it gained 4E. Still, if you're noticing it, the net charge is still 8E of the system. So in this case, if you're calling this as the system, the charge is conserved. A very important thing, a very, very important thing. Tricky questions can be given, and that we will have a look at a few tricky questions as we move into the session. Sure. So guys, are you feeling that I'm moving a little fast? I think I was assuming this is a basic topic, so I was just moving a little bit. I think so. Anyway, to give you a brief, few things you need to know about charges are charge is like a fundamental property, and the other thing is like charge is quantized. It will exist in the integral multiple of E, where the value of E is 1.6 into 10 to the power minus 90, and of the entire system. Like if I'm calling these two spheres to be a system, the amount of charge present in the system will never change. It will be 8E, it will be 8E only. Okay. You bring any other thing into the system, that will be also considered inside the system. So these are like the basic things, students. And the same is also true for a system. So you should not be grounding it, because if you're grounding it, you're changing the entire system. Let's say you're not grounding it, and still the overall charge of the system, even in an electrostatic induction, remains constant. We'll understand what is also electrostatic induction. So this is all about conservation of charges. So for an example, here you have 4 plus 4 coulomb and plus 8 coulomb. You have plus 4 coulomb and plus 8 coulomb. And now let's say you, so this is a system. This green and the red forms a system, let's say. And this system, how much charge does it have? That's plus 12 coulomb. So now let's say that you have brought them in contact, or something happened between these two systems, they collided, etc., and the green ball has become 10 coulombs. Okay, the green ball became plus 10 coulombs. Now what would be the charge on the red ball? Think about it. So 12 coulombs is the total amount of charges present in the system. The red one should have a charge equivalent to that of 2 coulombs. Okay, if I'm saying Q1 plus, so let's just write it down something like this. Just a way of indicating it. I'm going to call this as Q1. If I'm going to call this as Q2, and this as q1 dash, and this as q2 dash. So the thing is q1 plus q2, a very important property though, it's a very simple math I guess. q1 dash plus q2 dash. So that being said, this is plus 4 plus 8, so be careful about the signs. 8 coulomb, and this is q1 dash is going to be 10 coulombs plus of q2 dash. How much should be the value of q2 dash? Basically it's 12 minus 10, so q2 dash should be plus 2 coulombs. All right. All right, and that being said, this is plus 2 coulombs. That's it. Yeah, you can prepare for JEE Advanced using the notes, guys. Yeah, you can also find the notes. If you haven't found the notes yet, you can find the notes also on Unacademy Learning app. You can quickly you'll have all the notes on Unacademy Learning app if you haven't attended if you have attended the sessions over there. If you have attended the sessions over here and if you found any notes missing, you can quickly get onto Unacademy Learning app and find the topics that has been covered, and you can get the notes. Right? Yeah, it's enough, guys. It's enough. But yes, practice more and more problems. So one of the things, a good question. So is the notes enough? Is the lecture enough for your JEE Advanced preparation? More practice. So the recent trend, if you're noticing it, is JEE Advanced level is increasing day by day. I mean year by year. So what is happening is now there aren't any mastery following questions where you can use method of guessing, method of elimination, etc. So the probability of guessing has been reduced drastically in JEE Mains. So earlier, let's say 5-6 years back or 7 years back, it was all about just simple aptitude. I mean like conceptual and aptitude based things that you can have used to crack the exam. Now the thing is the exam questions level have increased recently in the past 2 years when it comes to physics especially. You'll notice the paper is also set in a way it is moving back to the subjective. Like most of the questions that are being asked or something that you can't, if it's multiple correct, then you're working out for a lot of time. But anyway, you have, the good thing is you'll be having more and more integer based questions which will be saving your time compared to MCQs. But that being said, guys, the thing is the difficulty level is also increasing year by year. So now yes, the notes can be enough, the lectures can be enough, but maybe attending intensive program is good, but still it's up to you how well you practice, how much dedicated you are. If you're on Unacademy Plus, how much lectures you're attending and how well you're practicing. Maybe it's the time to say that earlier during our time our lecturers used to say, or our educators used to say, maybe not Iradav, maybe it's the time to get back to Iradav, because you're moving to subjective level. The difficulty level has anyway increased until from the past time, but now the difficulty level is remaining the same and it is more of a subjective level paper and very conceptual and very mathematical as well when it comes to physics. The past 2-3 year paper, if you have noticed, is that kind of thing. So more and more practice will help you, more and more test series, get used to the environment for JEE Advanced. JEE Mains I believe is still the same, but anyway it's a vast syllabus when it comes to JEE Mains. So attend and complete the syllabus within the time. That's the key to crack the exam. Attend as many test series as possible. So that is it. That's all about conservation of charges. But anyway, let's do some interesting and practical problems for your on conservation of charges and everything concept that you have covered until now. So a particle physicist is studying a decay process. Okay. Now when it comes to a decay process, think about it. What is happening? A particle physicist is studying a decay process of a particle of charge. So initially there was one particle. If you remember, if you haven't yet gotten the subject, I guess. So typically, a particle can decay and form multiple materials. It can be radioactive. So the thing is, now there is a particle and it is decaying. It is forming multiple particles. And how many particles does it form? 3 new particles. So add some sort of reaction, it forms something like X, Y and Z. Alright. So A initially add a charge plus 5e and X, one of the particles among them have a minus 2e charge. So any guesses on the answer side, students? Good. Oh, sure. Yeah, try it out. Simple problem, but make sure you get the correct answer. Alright, it's always played with numbers, guys. JEE Advanced, JEE Mains, JEE Advanced typically is played with numbers. This I know is not a JEE Advanced or even a JEE Mains question, but that being said, a very basic question. It's played with numbers. If you're getting it wrong, you didn't. It's not just about the concept. You attended the lecture and understood everything. If you're getting it wrong, it's probably something to do with the numbers. Some numbers seem confusing for some reason. I don't know why, but yes. So that being said, this is going to be Z, and it should be, if you try to conserve the amount of charges, let's say this is the charges present on it, Z, it's going to be Z should be, you take it on the LHS side, 7E. Alright. Rohit, there you go. I hope you understood. It is going to be 7E, guys. Why would it be plus 3E? It is minus 2E charge, right? It's minus 2E charge. So don't get confused on basic things like that. That is why we have questions like this, students. A particle physicist, let me come to the question again. So it's like, you guys are smart, you guys are brilliant, but what is going wrong? One thing is, try to put your pen on paper, beat your JEE Advanced, JEE Mains question. If you find a very simple problem, just don't, just don't ignore the process of maybe solving it, unless and until you're very confident. If you're doing logical guessing, it makes sense that you don't have to put pen on paper. But let's say it's a very simple problem, maybe you can do, without putting your pen on the paper, just, mentally. Then also it's necessary sometimes that you put your pen on paper. This is a simple problem. So this was having a plus 5e charge. What happened? It decayed to form 3 particles. One is neutral, it carries no charge, so 0. The second one is going to be minus 2e. So what should be the third one? The amount of charge should be conserved. It should be plus 5e in this system as well, right? So minus 2e, ZC minus 2e should be 5e. So how much should be ZC? 7e, right? Right? Easy? Yes, that is why we have these kind of problems. But anyway, these are like very, very basic problems, and you may want to work around. Maybe just you had a look at this problem, maybe practice a couple of more problems. Maybe don't want to spend more time on conservation of charges and take up, maybe if possible, more complicated problems at this moment. So yes, guys, you can work out this question. This is a simple math based question. A conducting material has a net charge minus 6.4 into 10 to the power minus 17 coulombs. So this should be coulombs. And what is the approximate number of excess of electrons on the material? Okay, what is the number of excess electrons on the material? Okay, this is a very simple one. How would you do this? If you remember, you need to apply one of those principles that we have studied in the class. It's fine. It's totally fine, guys. I mean, Rohit, you did that capacitor quiz really, really well. But still, I'm surprised. The last question might have gone wrong for some of you. Given that, even though you understood the principle, you missed the math. Okay. So yes, guys. What is the approximate number of electrons on the material? You need to do the math a little bit, but still I believe you can take a hint would be take E to be 1.6 into 10 to the power minus 9. Okay, you can take E as 1.6 into 10 to the power minus 19 coulomb. I'll start working on this. So Q should be E. But yes, students, if you have just started attending class, stay dedicated, be it if you're on class or if you're just attending on YouTube. The reason is you don't want to even miss a single lecture on electrostatics, or be it in optics, be it in any of the subject. Try to maintain the completeness. Now the strategy is going to be maintaining completeness, not how much you work around. And this is going to be minus Ne in this case, because it's an electron, it's minus E. Okay, 6.4 minus 6.4 into 10 to the power minus 17, and on the denominator you would have 1.6 into 10 to the power minus 13. This is how much? 100. Still, okay. This is going to be 16 fours are this 6.4, 1.6, this 4. N should be 400 students, right? Simple. I believe you got this. This is how you find out the number of excess electrons or number of electrons lost, etc. in a given material. Alright, I believe the concept was simple. Anyway, at the end, I'll again brief you through the concepts, but we have more and more interesting questions, guys. Okay. So let's say now get started on this one, students. Good Rohit, really good students. This is one of the most important expression you want to remember. It sounds basic, but still you want to remember. This involves the principle known as quantization of charges. Okay, this is the quantization of charges property, so you want to remember this. Okay. Alright, anyway, with the next question, this concept will be more and more clear. And there it was. What was this question all about? Conservation of charges. Okay. Alright, let's get into the next question then. So there are two, get started on it, students. I don't want to tell you, get started on it. So there are two charged conducting objects. They collide and separate. So they collide and separate out. Before colliding, the charges on the two objects are plus 3e and minus 6e. Which of the following are possible values for the final charges on the two objects? Okay, whether it should be plus 4e minus 7e, or whether it should be plus 2e minus 2e, or whether it should be minus 1.5e minus 1.5e, and whether it should be minus 3.5e plus 2.5e. Any guesses, guys? What should be the answer? What principle does it involve? What is that principle that we are dealing in this case? Think about it. It's a simple one. So there are two objects, they collide, they separate out. Initially they add plus 3 and minus 6e charge, plus 3e and minus 6e charge on them. So once they collide and separate out, what is happening on them? There would be some transfer of charges, assuming. So anyway, it's given in the options that maybe there was a transfer of charge. So in this case, we are going to go with two principles. One is going to be conservation of charge, of course. It's an isolated system if you're just taking up both these objects and assuming there was no other charge transfer anywhere. So there's going to be conservation of charges, and the other one is going to be quantization of charge. So these are the both things involved in them. Okay, if you are carefully having a look at the options, if you are simply going by principle 2, both of them do not go with principle 2. They are violating principle 2. This is saying there is some plus half charge, or whatever it is, minus half charge present in it. In this case, it's plus half charge and minus half charge and plus half. Okay, so half of E does not make any sense. Alright, half of E, there are proposed particles like quarks, etc. They can have fractional E, but a system on a whole cannot have fractional E. Alright, as far as our exams are concerned, it cannot have minus half E and minus half E. So object A or object B, let's say that one of the object is object A and the other one is object B. Minus half E charge is not possible. Similarly, in this case, even though if you notice this is following conservation of charge, if you add up both of them, it's going to give you minus 3. Okay, what is the net? Let's say Q1 is plus 3 and Q2 is minus 6. What is the value of Q1 plus Q2? It is going to be minus 3. Alright. So it's going to be minus 3, right? So wherever you would get minus 3. This one also you are getting minus 3, but it does not follow quantization of charges. Whereas this is anyway not following conservation of charge. This is anyway not following conservation of charge, because minus 3.5 E plus 2.5 E is going to give you minus E. Alright. And what about this? Plus 4E minus 7E. What is the total amount of charges? It's minus 3. A should be the answer. So we have only basically covered two principles in this entire lecture. So one is going to be conservation of charges and the other one is going to be quantization of charges. So make sure you understood this one. If you're not getting it, it's based on both these principles. So by this problem, everything should be clear around this both principles. But let's have a look at more and more problems. You know what? This will make us perfect. There will be, of course, many confuse me problems. But before that, let's talk about something interesting. So how do you charge, let's say, an object? For an example, you have an object with minus Q. And there is another one, a neutral. Let's say they both are like, maybe identical or non-identical. One way is you can bring them in direct contact. Okay, I took this object with minus Q and brought it in contact with the neutral one. Then what would happen? You would see something like this on what you're seeing in the bottom. Okay, there would be some electrons that have been transferred to this green one, and that is the amount of electrons lost in the blue one. So the net amount of charge finally after bringing them in direct contact is going to be minus Q plus of Q dash, whereas on the neutral one, which was earlier neutral, has gained minus Q dash coulombs. You can find out the number of electrons by dividing it by minus E. Okay, so the thing is, you can bring in both conductors, in direct contact and transfer the charges. This is one of the ways to do it. Okay, but there are other ways as well. So one is electrostatic induction. What do I mean by electrostatic induction? So let's say I have a charged object like this in this case, and what would I do is I would bring a neutral object. It is at some distance. They are never touching each other. They are at some distance. Now what you're going to do is you hold it for some time. This will get polarized in the opposite manner on the side facing it. Okay, so this is known as electrostatic induction, a very popular phenomenon. Whenever you get started with electrostatics, probably this is the first thing that you're reading, since you're your secondary class. I mean, in your school. So all these experiments that we have been doing, all is like charging through induction. Still, the amount of charges in both the cases, of the total system remains constant. So this is one of the ways of doing it. One is by direct contact and the other is by electrostatic induction. Alright, but if you're noticing the face of the object that is facing this blue color sphere, which is negatively charged, has become positively charged, whereas the other side has got polarized as the negative. And the third one is going to be charging by frictions. And for an example, if you have a PVC pipe and if you're there are actually cloths, if you remember, you can rub them to make this rod positively or negatively charged. If you remember, I don't know, during our time, in our 9th and 10th classes, we have done experiments where we had a silk cloth on which you rub a pipe or a rod, and you typically observe and then you stick it to the paper, right? And the paper to notice whether the rod is charged or not. Okay, they get charged. So this is known as charging by friction. All right. So this is a typical simulation. You can just have a look at it. One time you have a positive rag and then you have a negative rag. You're rubbing it, and then you notice that that rag is becoming, okay, in this case the rag is becoming positive rag. But if you remember, we used to do silk cloth experiment where you used to rub the rod and that is known as charging by frictions. These are the three typical ways of doing it. But that being said, guys, let's get into a challenge problem again. All right. So there are two metal spheres of equal sizes with charge plus q and minus q, and they are brought in direct contact. Go through this session completely, students. The basic concepts around electrostatics should be clear by the end of this session. So make sure you are attending each and every question as well. Okay, that is very important, really very important for your understanding of the basic concepts. Don't miss out the questions since they sound very elementary or very basic, but they are going to get your concepts. And I believe, you'll be able to do all of the questions given that you understood the concept. You understood the lectures, etc. If you felt it was really a little fast or something, you could have slowed down the video, but maybe next time I'll take it a little slower because you're going to deal with more advanced concepts. So these are like the basic concepts that you need to know. So there are two metal spheres A and B of equal sizes. They're identical spheres, and one has plus q charge and the other one has minus q charge, and they are brought in direct contact. Then which of the following describes good, really good, Rohit, really good, really good. So which of the following best describes the transfer of charge? Option A, electrons flow from A to B. Option B, electrons move from B to A, protons move from A to B, and protons move from B to A. So C and D does not make any sense because protons do not transfer, protons don't flow. We assume that only electrons flow. Okay, so C and D are wrong. Good, Rohit. The answer should have been why B? So let's say you bought a plus q and a minus q charge in contact. The net charge of the system is 0. It becomes 0. How does it become 0 though? They're identical spheres, etc, etc, etc. Okay, plus q minus q, total charge 0. Once we bring them in contact, we'll understand that in moving forward why it would become 0, etc. But for now, just get it like, the amount of charge is conserved when identical conducting spheres are brought in contact and one has minus q charge and the other one has plus q charge, they will become 0. Okay, and okay, all right. So that being said, now think about it. What is happening when each of the spheres having 0 charge? Some minus q charge, q charge. Sorry, they would become. Just a moment. The net charge is 0 and they should be having same potential. So I think it is only possible when they are 0. That means some minus q amount of charges have flown to the plus q amount of charges. I'm really very sorry. So let's say there are two spheres and one sphere is this, one sphere is this. Now what happened was, really the protons didn't flow from this sphere to this sphere. Let's say this is A and this is B, but rather electrons did flow from B to A. All right, electrons did flow from B to A. So you understood protons don't flow, they have become 0. All right, try to understand this. Okay, even if you don't know this point of electrostatic potential, still electrons will only flow. Electrons will flow from the one that has excess number of electrons to the other one which has lesser number or does not have enough number of electrons. All right, really simple, really conceptual. So it does not flow from A to B. That is quite I think that there is no explanation required for that. So let's move on to the next one. I think there is something wrong. I think this was the picture that was supposed to come up. Technical issue, I guess. PPTN. So anyway, so this was the picture that was supposed to come up. There is a sphere A plus sphere B. They are brought in direct contact. So what happens after that? Yes, again we'll have one such thing. And so the thing is now try to answer this question. So now you have two identical spheres of equal sizes, equal masses, everything. Identical spheres. It should have been identical spheres. Anyway, only I think the size matters and the kind of material matters. But anyway, coming to your exams, it should be of equal sizes, and one is plus q and the other one is plus 2q. They are brought in direct contact. Then which of the following best describes the transfer of charge? So just we discussed now. So 4 options are given, the same ones. Electrons move from A to B, electrons move from B to A, protons move from A to B, and protons move from B to A. Of course, you know, protons don't flow as we just discussed. So in this case, what would happen really is, this is more positively charged, this is less positively charged. That means this has more number of electrons compared to this. So electrons will actually flow from A to B. As you know, protons don't flow, so electrons will flow from A to B. Alright, really simple. It's A to B, Madhu. Okay, A to B, guys. I hope this is clear. The plus Q charge sphere, has more number of electrons compared to the plus 2Q charge sphere. Okay, let me repeat it again. The plus Q charge sphere A will have more number of electrons compared to the plus 2Q charge sphere B. Alright, in the earlier case, it was minus Q and plus Q, and it was obvious that B has more number of electrons, and electrons only flows, so electron would flow from B to A. Alright, really simple. So let's get into the next question. It's an interesting one. Try to have a look at the question. Take a couple of minutes. That's fine, Madhu. That's totally fine. But do go through the session again, guys. If you didn't get these concepts, they are basic concepts, but very important one, will be useful in future as well. So yeah, and try to answer this question. It's an interesting one, and I think there are two metal spheres in this case of equal sizes with charges plus Q and minus Q, and are brought in direct contact. Then which of the following is true after direct contact? All that questions can be this tricky some or the other way. This is something that you may want to answer it. Come on, students, get started on this. This is a simple one, I guess. This is really, really simple. Would the mass of the system remain constant? Overall system remains constant. Let's say mass of A and B remains constant. Okay. Good. Really good. Really good. See, Madhu, the system should remain constant. It's my mistake. It should have been A and B. Okay. Really good, Rohit. Really good. So what is happening once you bring both of them into contact? Electrons are going to flow from B to A. Okay. If electrons are going to flow from B to A, what would happen to the mass of B? B's mass would decrease because electrons have mass. Electrons are not massless. Electrons have mass. Isn't it, guys? So along with the transfer of charge, some mass is also being lost. I mean, like, if electrons are flowing, the mass is also being lost. So mass of B would decrease. Right, since it's B to A, the electrons are flowing. Yes, you are correct, Madhu. Given that entire system of the whole system, the mass would remain constant. The number of electrons flown is the number of, the number of electrons lost is the number of electrons gained. The mass would remain constant. Right? We are talking about both A and B. They don't remain constant. Mass of A and B together don't decrease. Actually, the A would be gaining some mass, whereas B would be losing some mass. I hope you understood this concept. Okay. Electrons are mass. Once you're bringing them in contact, this is clear that electrons flow from B to A. And then in that case, what is happening? B is losing the electrons, A is gaining the electrons. So B's mass would reduce, whereas A's mass would become more. Okay, this gains not only electrons but also mass. This is losing both electrons and mass. Really simple, guys. Okay, yes, it is true, like what one of the students has told. Mass of the overall system would remain constant, as does the charge. Okay, I believe by now every concept around this basic thing is clear. If not, go through the lecture again, students. Let me quickly brief you through what all we have done today. One, we have understood what is charge, basic definition of charge. And what is charge? So charge is saying that if a system has charge, then it would experience a force in electromagnetic field. The next thing is we also saw that charge's property. One is charge should exhibit like an electrostatic repulsion or attraction. Like charges repel, unlike charges attract. Positive and positive charges would repel. Negative and negative charges would repel. Since they are like system with like charges, positive and negative charges would attract. Okay, since they are unlike charges. Now that being said, we also understood the charge of the entire system, the overall system, would remain constant, and the charges will also be transferred or flowed from, let's say there are, in this case, these two spheres are brought in contact, but still the overall system has zero charge. Even at the end it will have zero charge. And that also being said, the charges always are transferred in a quantized manner in integral values of E. Now the value of E was 1.6 into 10 to the power minus 19 coulombs. And let's say 1 coulomb has been charged, 1 coulomb has been transferred, then in that case 6.25 into 10 to the power 18 electrons flow from one, like from somewhere to the other place. Alright, these were the basic concepts that we covered in this thing: quantization of charge, conservation of charge, what is a charge, properties of charge, and the last and the most important one is charge is relativistic invariant. What do I mean? Regardless of how fast the particle moves, the value of charge does not change, even though the mass does change. Okay, so this is a very I'm not sure if this concept is required for your JEE Mains or JEE Advanced, but this is a very scientific and a very important concept, that any particle that has the same amount of charge would also have the same amount of charge irrespective of how fast it is traveling, even if at the speed of light. So this is a relativistic invariance property of a charge. Okay, so this is also a very interesting one. This is one of the most interesting things about charge. So yes, I guess now the basics of charge should be clear. We'll move into a little bit more advanced concepts. I think they are also not very advanced, given that you're attending the lecture from the beginning. So stay tuned, guys. Attend every lecture. Do like the video. Do share the video, because we have started with something new, and it's a free of cost initiative. JEE English is a free of cost initiative. So do share this video, talk about this channel. You can also share the channel. So do share the channel. That is also very important, because someone in need may get access to it. And guys, keep smiling, avoid gossips, work hard and smart to achieve your success. And that being said, students, I'm going to launch a plus course on optics. Do not forget to attend it. If you're on plus, or if you're planning to enroll soon and attend the coursework. It's going to be super interesting. And students, if you are on our Telegram channel, well and good. If not, do click onto the link available in the description box below. First of all, you need to have our Telegram app. If you don't have it, download it from your Google Play Store and App Store, and then just click onto this link that is available in the description box below. You can also find us by just typing in JEE_English. This is going to be the place where you're going to find all the updates happening on JEE English every day. Be it strategy sessions. Tomorrow we are going to have an awesome strategy session for you, so don't miss it out. Be it 2021 aspirants, also 2022 aspirants, do attend it to understand what is going on in JEE Advanced right now. So don't miss out things like this. I'm going to conduct an extensive analysis. I'm also in certified like an AI engineer, so I'll be conducting extensive analysis for you guys. Don't miss it out. But I think it's a very low like a data analysis thing. But anyway, do attend tomorrow's lecture. Don't miss it out, and you will get all the updates on this one place, that is going to be your Telegram channel. And that being said, we have covered guys, A to Z of units, dimensions and measurements on a back-to-back sessions from 19th to 22nd of September. And this Sunday we might you'll be having a DPP or a problem set session on units, dimensions and measurements. One of the most important things is dimension analysis, be it for JEE Mains and JEE Advanced, also error analysis. All of the topics are very important and they are very easy. They're very easy to score. This is literally 12 hours, guys, and everything is covered. Little more than 12 hours, but everything is covered within 12 to 15 hours. And this 12 to 15 hours can fetch you anywhere around sometimes 4 marks, 8 marks in your JEE Advanced, and even a little bit more in your JEE Mains. And this combined with basic topics which are going to be super easy will fetch you that kind of marks that you need. And you can find the session on Unacademy Learning app. Students, if you don't have one, do download it. We have very interesting features for you, free of cost interesting features for you. One of the special classes, you can find many such special classes conducted by many educators. And the beauty is, if you have this Unacademy Learning app and if you follow the educator, you'll get timely updates. So do follow the educators as well and install it. All you need to do is search Unacademy on your Google Play Store and App Store. The first search result is going to be Unacademy Learning app, and then you'll choose this link and click on the install button. And that being said, guys, we also have quiz feature. You may want to try it out. We'll have quiz in every class, so don't miss out any of the quizzes. These are all amazing things that you have for your exam preparation. And that being said, students, if you're preparing for an exam and seeking out for a champion's tool for your JEE preparation, be it mains or advanced, we have one. We have the best educators and teachers across the nation on this single platform. It comes with everything that you need for your JEE preparation, be it your mains or advanced. You get to attend a structured program where you will get to attend quizzes in a very structured manner, and you will get doubt clearing sessions, and you can also get your doubts cleared from the best educators across the nation. And we also have authors, the books of the authors that you study on our platform, like DC Pandey sir and etc. on this platform. And it's an amazing platform equipped with the state-of-the-art technology. And what is this thing? This is a subscription. And how do you avail this? All you need to do is click on the extension box. Yes, Sabrish, after electrostatics, students will get started on magnetism. I thought of bringing up magnetism, Sabrish, but the thing is, I thought this is a basic thing that we should cover before covering magnetism, because that will sort of give you an understanding of magnetism as well. If you make a transition from electrostatics to magnetism, it would be far better than just directly starting with magnetism. So you'll click on the extension bar, you'll choose plus, and you'll choose your goal as IIT JEE. But don't worry, Sabrish will be covering pretty much every concepts in electrostatics. And then post that, you will get the subscription, guys. That's all you need to do. And with that, you'll get ready for your JEE Mains preparation. We have n number of programs for your JEE preparation. You'll enroll in them according to your plan. And that being said, the best plan is going to be 24-month program, especially for 11th class students, 10th class students and 9th class students. And guys, it's only going to cost you 2,100 per month. It's quite reasonable. And how do you get to this price point? You'll apply Murli Live coupon, and with this you'll get the best discount on your subscription purchase. And guys, that being said, we also have very convenient payment methods for you. One is going to be pay in parts, where you can split your payment into multiple parts and reduce the burden of paying all the fee at once. And we also have no cost EMI options, so you can choose no cost EMI, and with that you can also split your payments into multiple parts and avoid the hassle of paying all the fee at once. So these are some two amazing payment options that we have for you. But we also have other payment modes like debit card, credit card, UPI, etc, etc. And that being said, guys, if you're in 12th class, or if you're a dropout on long term, and if you're only planning to prepare for 1 year, we also have a reasonable package for you that's going to only cost you less than 2,900 per month. I'm sorry. So it's going to only cost you 2,888 per month. And how do you get to this price point? You apply Murli Live coupon to get the best in class discount on your purchase. And that also being said, we have 6,000 plus materials for your JEE preparation, more than 6,000 plus materials actually. And we have 1,000 plus live programs going on plus, so be sure to attend them, stay regular. It's a structured program where you get to go by the by that extensive and intensive preparation. So don't miss out any of the sessions. That's very important. If you're already on Plus, do attend the test series, do give the quizzes, come to every class, and it's going to be I think an amazing experience for you on a platform like Unacademy. So don't miss out the opportunity. Enroll soon, students. See you in the next class. We'll come up with more and more interesting lectures for you. See you. Take care. Stay safe. Bye bye.